Good afternoon, everybody. My name is Mark Frigdenhall. I'm the publisher of Plumbing and HVAC magazine, and wanted to thank everyone for coming to this session. We have David Kim leading off the session. He's the engineering manager at LG Electronics Canada. And David graduated from the University of Waterloo with a mechanical engineering degree and has worked in the HVAC market with LG Electronics for the past 8 years, supporting engineers to apply VRF applications in Canada. And I will turn it over to David now. And again, if anyone has any questions during the presentation, please add them to the chat. We will deal with questions at the end of the presentation, but I will take note of them throughout. And if there is any issues with hearing or audio or so on, usually refreshing the page is a quick solve to solve most of those issues. So if you have any problems, you can also, though, let me know in the chat, and we'll make sure we work it out for you. So that's it. I will turn it over to David, and please don't forget to ask questions.
Thank you, Mark, for the introduction. Hello, everyone. Thanks for joining today's training about the A2L refrigerant safety system design and some of the application. My name is David Kim. I've been working with the LG Electronics for the past 8 years. I've been supporting the sales, discussing with the HQ on the R&D, supporting the applied reps, consultant engineers, and all that in the past year. So hopefully the message today about the new refrigerant will be very helpful for your day-to-day lives. So today, I'll be going over some of the A2L refrigerant, why we're changing, to what we're changing, and how we're changing, and some of the applications with the new refrigerant and what you guys have to look out for when you're designing or installing the new refrigerant. So just to start off, why? Why are we changing? Let's go back in history and back to 1987 when the Montreal Protocol came out. So back in the days, it wasn't the global warming that was an issue. It was the ozone layer that was an issue. So that is why through the Montreal Protocol, they have decided to phase down the FCFCs, which had the chlorine that destroys the ozone molecules, right? So the Montreal Protocol kind of forced us to phase out the R12 or R22. And then as a result, we started using the R410A. And as per the UN, this Montreal Protocol is considered as one of the most successful protocol in the history, because as per UN, as I mentioned here, if the current policies remain, we're bound to go back to the original ozone layer by 2066, right? So the ozone layer is recovering due to this Montreal Protocol, and it has been very successful. But then that was with the ODP, the ozone depletion potential. Now we're focusing on the GWP, the global warming potential, and that's why the Kigali Amendment came out in 2016, and it required us to utilize the refrigerant with a lower GWP. The refrigerant that we were using commonly was R410A, which had the GWP of 2088. 2088 may seem high or low to someone who does not know what it means. The GWP basically means it's a global warming potential. And whenever we talk about the global warming, we talk about the greenhouse effect. And the chemical that brings up more frequently during the greenhouse effect is the CO2. And CO2 has the GWP of 1, which means if the same amount of the refrigerant CO2 has been released to the atmosphere, the R410A has 2088 times more likelihood to cause the greenhouse effect, right? And that is one of the reasons why we need to phase it out. However, there's an issue in Canada. So Canada ratified the Kigali Amendment back in 2017, and then they promised to control the import, manufacture, and then use of HFCs with a high GWP. And then they have given out some of the scheduling to limit the GWP for certain equipment. However, the schedule that was sent out by the Canadian government did not include the mini splits or the VRF systems. On the other hand, on our south border, the US, they ratified the Kigali Amendment later than Canada, but then they have included much more detailed information on the GWP limit for each of the product category, which included the mini splits and also the VRF equipment. And as per them, they had to phase out any equipment utilizing the GWP refrigerant higher than 700 starting from January 1st, 2025, this year for the residential and light commercial air conditioning and heat pump, and then variable refrigerant flow systems to be followed by next year. So in Canada, we theoretically we can still use R410A because there hasn't not been any mandate. But then because the U.S. The mandate has already been starting from this year, we're seeing some effect and on the equipment selection that we can do in Canada. So what it means, what is A2L? So if you go to the ASHRAE 34, it kind of gives you the breakdown of what each class represent. So class 1 means it's a refrigerant with no flame propagation. It doesn't mean that it will absolutely never ignite. It will ignite, but then it won't just ignite or cause any flame propagation at the given tested condition. And some of the popular version includes R410A and R22. And there's two different categories under class 2 is there's 2L and 2. Both are lower flammability. It's just that 2L compared to 2 has a lower burning velocity. So it's less flammable compared to the class 2. Some of the popular refrigerant in the class A2L, 2L is R32 and R44B. And obviously the class 3, the last one, is highly flammable, which includes the propane and butane. Okay, so there's a difference between all this refrigerant. And one of the key things that differentiates, as I mentioned, between the class 2 and class 2L is the burning velocity. So if you see the graph that I'm showing you right now, you can see that the R32 and R44B both has burning velocity less than 10 centimeters per second, whereas the propane has almost close to 40 centimeters per second. It just means that the R32 and R44B, so all of the A2L refrigerant, will be slower in spreading the frame horizontally in comparison to the A3 refrigerant. So that itself really represent that it's a really safe refrigerant. And not only that, we can talk about the LFL, the lower flammability limit, and also the UFL, upper flammability limit. So each of the refrigerant or these chemicals requires a certain concentration within the air for it to ignite. And that is what we call the LFL and UFL. The concentration has to be within that flammable range for it to ignite. So if you see the bar graph that I'm showing you right now, acetylene, isobutane, natural gas, they all require very small concentration for it to ignite, whereas the R32 as a representation only requires 14%, which is greater than any of the A3 refrigerant in there. This 14% is the LFL in the percentage. And then if you just want to go with the traditional pounds per thousand cubic feet, that's a 19.1 pounds per thousand cubic feet, which means that the 19.1 pounds of refrigerant has to be present in the 1,000 cubic feet for it to ignite. And the two refrigerants that's common in the market right now as an A2L is R32 and R454B. They all have the GWP less than 700. R32 has a GWP of 675, and R454B has a GWP of 466. And both of them has zero ODP. The one that I want to kind of focus on is the refrigerant concentration limit. So this RCL is basically the refrigerant that is allowed to have in the house or in the room as per the B52 code. The RCL of the R410A back in the days was 26 pounds per thousand cubic feet. Okay, and if you look at it, R32, 4.81 and 3.06 is significantly less compared to the R410. So if you think of it that way, think about a room of 1,000 cubic feet. And back in with the R410A, you could have 26 pounds of refrigerant leaked into that room. But now with the A2L, you can only have 4.81, right? But later on this presentation, I'm gonna showing you, explain on how you can manage that issue and allow more refrigerant inside that room. Just to show how safe this refrigerant is, with LG, we did a safety analysis test where we placed the warm-out unit inside the chamber, placed multiple candles, and leaked the R32 refrigerant in it. And when the refrigerant was leaked, It did not cause any explosion. It did not cause any like those big explosion that you see in the Hollywood. But then all it did was to increase the flame height. You can see on the top left corner picture where the candle flame has increased in size. And that's basically all it did. It fueled the flame. It did not cause any chain reaction, but all it did was to fuel the flame to make the flame bigger, right? It has been a very safe testing. And R32 or any of the A2L refrigerant was already being used in the different regions in globally. European has been using the A2L for 7+ years. But I don't recall seeing any newspaper saying that the building has blown up because the flame caught into the A2L refrigerant, right? So A2L, just that being said, is a very, very safe refrigerant to use. However, because it is considered as the A2L refrigerant, some of the standard had to be updated. So the UL 60335-2-40 has updated, and ASHRAE 15 was updated for US team, and the CACB 52 code was also updated back in 2023 to talk about or to kind of show the mitigation strategy with the A2L refrigerant. Now, I'll be going some of the key things that I found on the CACB 52 code and how it will impact on utilizing the A2L refrigerant in our day-to-day installation or design condition. Some of the things that I'm showing you is directly from the code itself, but then this presentation is not the copy and paste of the code, so I might be missing some of the information from the code, but this is what I found that can impact the design of the A2L refrigerant. So within the code itself, it has the flow chart that kind of gives you a guideline on how you should design using the A2L refrigerant. But on our, I'm not going to go into a detail of this flow chart, but basically you can kind of skip through the main portion of it because it doesn't really apply to the minute splits. But this flow chart also kind of gives you the new introduction of the EDVC, effective dispersal volume charge, which I'll go ahead and go into a detail about how you can calculate that in a later slide. And then the release and mitigation control, and then the new concept of MREL. And then I'll go into the more detail in a later slide. So first thing is the EDVC, the effective dispersal volume charge. Remember how I mentioned to you about the RCL of the R410A being the 26 pounds per 1,000 cubic feet? That was our rule of thumb value to use whenever we're designing or installing with the R410A equipment. Now we're using the EDVC control formula for it. So by using the volume on LFL, the lower flammability value, we can calculate how much charge the one volume can have using the A2L refrigerant. However, the condition to use this formula is to have either one of the condition. Number one is air circulation initiated by the refrigerant detector or the continuous air circulation. Now, this is not a ventilation or anything like that. It's just to cause the air circulation within the room. Now, many of the manufacturers, including LG, we have a leak detecting sensor built into our indoor unit and also has a logic to initiate the fan when the leak is detected, which means that we can use this formula for the system. And if I use this formula and calculate the charge and the maximum charge that I can have for 1,000 cubic feet, I get 9.6 pounds per 1,000 cubic feet, which is the double of the RCL of the R32. Okay. However, this 9.6, 9.55 is still smaller than the R410A, which is 26 pounds per 1,000 cubic feet. So what can we do? What is next step on making the A2L refrigerant more acceptable in the market? Second option is to use the natural ventilation. So if you have any opening on the wall or undercut under the door that satisfies this formula as per the area, you can consider the room next door as a one volume. So for example, I have put in the formula here as an example. The room with the 250 square feet with a 10-feet ceiling is a volume of 2,500 cubic feet, right? When I calculate for the EDVC, I get 23 pounds of refrigerant as a maximum amount. And for example, let's consider the system with the 25 pounds. Just by that, my system is not complying with the B52 code. However, if I have a ventilation opening that is greater than 0.125 square feet, I can still consider, or I can still install this 25 pounds of system inside the zone if the room next door is big enough. So this allows me to connect the next door volume as a one volume when I'm calculating for the EDVC. Next one is using the centralized ducted system, right? As per the code, if you are utilizing the centralized ducted system, the rooms where it is connected to can be considered as a one volume. Not only the rooms, but then the supplier duct volume or the return, if you have a returner duct, it can also be considered as a one volume, which means that rather than just utilizing the EDVC calculation focused on the small room, now you can add in all these 5 rooms that I'm showing as an example as a one volume, which means we can accept higher refrigerant volume into the system. Next is the mechanical ventilation concept. So this is not natural ventilation. This is not the air circulation, but then this is the actual mechanical ventilation. So it also gives you the formula to use to see what is the airflow that is required to be accepted. For example, let's again go back to an example saying that I have a system of 30 pounds. And when I calculate for the EDVC of the room, I get 27.5 pounds, which means as I mentioned again, it's not complying with the B52 code because I'm over by 2.5 pounds. But if I use this formula to calculate the airflow, and if I have a mechanical ventilation of 65 CFM, even though I have 30 pounds of refrigerant into this room, I'm still complying with the B52 code because I have this mechanical ventilation that can only, it doesn't have to be continuous operation, but then as long as it is initiated by the leak sensor, I can still comply with the B52 code. And lastly, is the concept of the shutoff valve. Okay, this is going to be a big change compared to the existing R410A system. So think of it this way. If you were using the R410A without the shutoff valve, and if there was a leak happening on the indoor unit on the multi-split system, you will be seeing entire system charge leaked into that single room. However, if you use the shutoff valve kit, and if valves are closing, once the leak is detected, only the refrigerants inside the remaining branch that will be leaking into that room. So that you just have to consider 3 things. The leak that occurred while the refrigerant leak is detected, leak occurred while the shutoff valve is closing, and leaked refrigerant leak amount that is leaked after the valve has closed. If you combine all 3 of those, you can get the total amount of refrigerant that will leak into this room. And that is not the entire system charge. That is a smaller charge that remains in that branch. And that's something that we call MREL. MREL means releasable refrigerant charge. I've done many of the examples in the past, and using the shutoff valve will dramatically decrease the amount of refrigerant that is leaked into this room. And I'm going to show you a couple of examples in the later slides on what you can expect. And then going into the IEC 60335-2-40, both UL and CSA 60335-2-40 refers to this IEC international standard. So basically, the key difference between the B52 code and then the UL or CSA 60335-2-40 code is that the B52 code actually looks into the volume. Okay, it goes by 4.8 pounds for 1,000 cubic feet, or it gives you the minimum volume that you can have. Whereas this code goes by the area, minimum area that you can have. So it also has this flow chart that you can follow, but then it's a little bit different to what you can expect on the B52. But then basically the concept of the circulated airflow, the total ventilation, the concept of the shut-off valve is present. It just has a little bit different formula to use when you're calculating for that minimum area. So rather than we're calculating the volume, we're calculating the minimum area by the total charge or the releasable charge, and then utilizing the height of the indoor unit or the height of the discharge point to calculate this minimum area. Let me show you some of the application examples. And obviously, these are just the examples that I personally made. And obviously, in the real life scenario, you're gonna be facing a different type of requirements. I'm just going to give you some of the examples on what you can expect. Let's say this is a two-story house with 3 bedrooms, a couple living rooms, couple of washrooms, kitchen, and everything, right? The total square feet of this room is, let's assume, is 1259 square feet. Let's assume there's a 9-foot ceiling. You can have, I'll say, 2 or 3 different scenarios, one with the wall mount units and a multi-split application, and one with the one centralized ducting system. Let's review both cases, but then first, let's go into an example with the multi-split. Okay, with the multi-split, let's assume, again, I'm going to be installing 7K wall mount units per room, 12K on the second floor family area, and then 2 ton on the first floor, covering off entire first floor. And obviously, as I mentioned multiple times, there's a different ways to design this. And this is just one of the example. And when I use this, using the selection tool that each of the manufacturers can provide, LG, we also have a selection tool called LATS. And if I input the information in there, it will automatically gonna calculate the total refrigerant charge into this entire system. And the total refrigerant charge of this entire system comes out to be 11.57 pounds, okay? And then if I were to assume that there is no shut-off valve and just using it as is, if I calculate each of the volumes, I can see that some of the rooms are not meeting the B52 requirement. The first floor and then the family room plus the washroom, the volume is big enough to accept that entire 11.57 pounds. However, each of the rooms are too small to accept that 11.57 pounds. So if you install it as is, it's going to be an issue. However, what you can do is, as I mentioned, to utilize the shut-off valve kit. Okay, if you use the shut-off valve kit, it will dramatically reduce the amount of refrigerant that goes in there. And then when I calculate what the releasable charge is going to be, each of the rooms, because they're the same capacity, and then the location of the valve, I placed it 2 feet away from the indoor unit, so theoretically they'll have the same releasable refrigerant charge. The MREL comes out to be around 1.93 pounds, which means the minimum volume that I can have with the shut-off valve kit can be calculated to be 201 cubic feet. As I mentioned in the previous chart, the volume of each of the rooms are much, much bigger than 200 cubic feet, which means that if I use the shut-off valve kit, I can have all of the rooms to be complying with the B52 code. And this is not the only method that you can use. As I mentioned earlier, if you have a greater undercuts below the door, or any of the natural ventilation opening, you can consider the room next door as a one single volume. In that case, you may not even require a shut-off valve kit because the volume itself now will not only just utilizing the room volume, but also be considering the room next door, like a living room or the family room. So there's a ways to navigate through to not to use the shut-off valve at the same time. On the other hand, if we are to use the vertical A2 single split unit, the total refrigerant charge itself is very, very smaller than the multi-split application. So, and also not only that, we're not using a single room as a one volume, but then because this is a centralized ducted system, we're looking into the entire house volume, not the room, not the living room, not just the family room. We're looking at the entire house volume, which is going to be all bigger than 828 cubic feet. right? Utilizing the vertical AHU as a single split, it will be much more acceptable throughout the build, utilizing the A2L refrigerant. Now, I showed you all this formulas, uh, checking methods, and all that. I don't remember all those formulas myself too. I don't expect any of you guys to remember and then go back and then calculate the refrigerant charge every single project, especially when you're doing the residential consultant. You might be able to go in and then do the calculation and then try to figure out what to. It's not a great method. That is why each of the manufacturers are developing this refrigerant checking method. With LG, we call it a LATS R checker. This is a web-based platform where you can easily just go in and then just type in the information and then see whether if your system is complying with both UL or ASHRAE 15/B52 code. So if I input the same thing as I did previously, for example, this is the application that I'm using with a multi-split wall mounted units. I inputted the 7K. The total refrigerant charge is 11.57 pounds. Let's say I put the releasable height at 6.58 because that's the minimum height that LG require for the wall mount units. And then if I input the room area and height with the shutoff valve information. That's all you need to input, and then it will automatically calculate for you whether if it's possible or not possible, right? And then it will also give you how close you are to fail. Right now with this system, I am safe enough. I have a lot of rooms to play around with it when I'm designing or installing. Similarly, if I go to the vertical AHU application, right? If I input the same information, and then on the area portion, I'm not going to be putting in the 108. I'm really putting in the entire house area because that's the centrally inductive single split system. If I input that, again, it'll show me a pass. But what about the other scenario? What if it fails, right? So let's go back to the original example that we did with the multi-split system with the wall mount units, and try to apply the scenario where we don't have the shutoff valve. So the same information as inputted as the first one that I did with the R checker. It's just that I did not input any of the shutoff valve information. And in that case, obviously it's going to show me that the installation is not possible. It's going to give me a fail. So it's a one quick way to check whether if your system or if your design or installation complies with the both UL or B52 code. And I strongly encourage you to bring your cell phone. It's web-based platform, so you can utilize this anywhere as long as you have an internet or cellular connection. Um, just input the information that you did and just quickly check whether if the installation is possible or not possible. Okay. As an in conclusion, just want to go over these points that I mentioned earlier. The Canadian government has not yet announced the phase-out schedule for mini splits and VRF for R410A in Canada, but the A2L refrigerant is commonly being introduced in Canada right now because of the U.S. Even though it is classified as lower flammability, it is a very, very safe refrigerant to use. So you don't have to worry about it blowing up the entire building. The B52 code and the CSA UL code has been updated to adopt the change in the A2L. And please make sure to follow each manufacturer's guideline and check if their system is compliant with the codes or not. And also always go by the regional building code as well. So those are the conclusion that I wanted to say. And LG, we have upcoming training sessions. So if you're more interested about service and some of the product lineups that we offer, we do have in-person training coming up on May 23rd, and also online training happening on May 30th. So I have a QR code up here right now. So feel free to grab your cell phone right now and take a picture of this QR code to register. So I hope you guys come in and then get more information about more detailed training about the LG products lineups and also the service changes that's happening with the A2L. So thank you very much, and I'll leave this slide open just then to give you guys some time to scan that QR code. If you guys have any questions that you want to ask in, please feel free to type a chat so that I can answer them for you.
Yeah, thanks, David. That was a great presentation. Yeah, we did have a couple questions throughout it, and please, if there's any more questions, we certainly have some time left. So please add any questions to the chat, and we'll go through them. Victor had a question, and Charles had commented, is what if there's a disagreement in the allowed volume of refrigeration between B52 and the UL 60335-2-40? Which one should they use?
I would say that, okay, first things first, as I mentioned earlier, the B52 goes by the volume, and then the UL goes by the area. So you have to comply with both. You cannot just say that, oh, B52 allows me to install. I can just not care about the UL or vice versa. You have to comply with both B52 and UL. And that is why the R checker gives you both options to check UL and the B52 to make sure it complies with both. As I mentioned earlier, B52 is volume, and then the UL is area. So it's a different criteria, but you have to comply with both.
And just maybe if you can comment on this, Charles had commented that OBC 2024 still references in the wrong CSA standard, and maybe if you could comment on that. He said that we ignore the OBC and we use the latest CSA standard, or and wanted you to.
Well, I don't have a full knowledge on the OBC, I'll be honest with you. However, I know that the latest B52 code actually refers to the CSA 60335-2-40. Down in the States, the UL, they have multiple editions as well. They have an issue with the 3rd edition and 4th edition and which edition they're going to follow. As per my understanding, the Canada do not have any edition mentioned anywhere. Correct me if I'm wrong, but as per that, just follow the latest edition of the UL. That's what I would like to comment.
Okay. And we did have one other question. I know this will be covered in the next panel session, but if you had any thoughts on it, the requirements for warehousing large volumes of A2L refrigerants, like for wholesalers and contractors, any requirements that you would know about storing them or warehousing?
The warehousing portion, no. Like I don't have a lot more information on that portion. Sorry.
Okay.
As Mark mentioned, I think it's going to be covered in the next session or so. So I think that's going to be answered in that session.
Yeah, we will certainly. We're going to talk everything from manufacturing all the way to reclamation in the next session with a great panel. We'll have wholesalers on it. We'll have manufacturers on it, contractors and reclaimers, and some refrigerant expert too. So that will certainly, I know that is covered in the next session. And we also have a question around Energy Star certifications. Many heat pumps that we're selling in 410A received Energy Star ratings at 4.5 SEER and higher. With the R32 refrigerant, I'm only seeing Energy Star ratings at 16.5 SEER and higher.
Correct. Even with the R410A, starting from the 2023, I mean, the Appendix M1 came out where we started to use the CER2, HSPF2, ER2. We're no longer using, CER, HSPF, or it's ER. And the Energy Star requirement has also been changed as the Appendix M1 testing standard has came out. I have not heard or knowledge about any of the Energy Star requirement changing with the A2L. They will still have the same requirement as R410A. I don't think there's a separate Energy Star requirement for A2L specifically. Correct me if I'm wrong, but that's as per my knowledge.
Okay. Any other questions from anybody? Yeah, this was really informative. Okay. So definitely, yeah. If you're looking for more upcoming training sessions from LG, certainly scan that QR code and check that out. And we still have some time left in the session if there are a few more questions. If not, I guess everyone's earned a little bit of a break before we head to the next panel session. which is we'll be starting, I guess, in about 25 minutes. So anyway, I wanted to thank you, David, very much for coming on and sharing your knowledge. It has been great, and we appreciate it very much. So thank you again.
Thank you very much for having me. It's been my privilege to share.
Okay. Well, everyone, then I guess I will end this session then. And please come and join us at the next panel session starting in about 25 minutes.
Thank you.
Thanks.